Hello everyone. Today we are going to throw some light on advanced normal forms. We have seen up to the basic normal forms like 1NF, 2NF and 3NF. Today we'll discuss about Boyce chord normal form, which is called as BCNF. BCNF is a superior version or advanced version of 3NF. It was developed by Raymond F. Boyce and Edgar F. Chord to tackle certain types of anomalies which were not resolved with 3NF. Now, when do I say that a table is in BCNF? First and foremost, the table should be in third normal form, and every right hand side attribute of a functional dependency should depend on the super key of that particular table. Now, what is this particular rule? A relation is in BCNF if it is in 3NF, and every functional dependency x determines y, x should be the super key of the table. Okay, let's try to understand particular thing. Look at the table example where I have got employee ID, employee country to which he belongs, employee department, then department type and employee department number. So the functional dependencies are like this: employee ID determines employee country, and employee department determines which department type and what is the department number. The candidate key is going to be employee ID and employee department, because employee ID can determine the country and department can determine the department type and department number. Now the table is not in BCNF because neither employee department nor employee ID alone are keys. Okay, they are together. We see that they are the composite primary key. So when I see this, to convert this into BCNF, I just split the table into three different things. One is country, because we said employee ID determines employee country. So I put that as a separate table. Employee department determines department type and department number. I put that as a separate key. And employee ID determines employee department. Now if you see, the functional dependencies are employee ID determines employee country, employee ID determines employee department, and employee department determines these two. These are the things. So when you see this particular thing, all these candidate keys are on the left hand side. So when I say that it is a super key, so BCNF is fully followed here. There is no other dependencies. This is already in 3NF because there is no transitive dependency, there is no partial dependency. Every cell has atomic value. All these things are followed. That is why now even the super key concept is also followed. That's why it is a BCNF. Now let's try to see what is fourth normal form. This is next level after Boyce chord normal form. Generally what happens is, most of the tables, if they follow up to 3NF, it is sufficient for us for general data, general tables. But there are certain tables or certain databases store certain data in such a way that there is lot of multiple values on independent columns. Such a situation is to tackle that situation, we go with fourth normal form. So fourth normal form comes into picture when multi-valued dependencies occur in a relation. So what is this multi-valued dependency? For a dependency A determines B, if for a single value of A, multiple value of B exists, then the table has multi-valued dependency. But here there is a constraint that in more than one column you will have multiple values. That is, it should have at least 3 columns for it to have multi-valued dependency, because one, if you think as your primary key, then there should be 2 independent columns which are going to have multiple values, and B and C should be independent. That is where what you have seen with science you have cricket, with maths you have hockey, but same student. But I say that with science he should have cricket, with science he should have hockey. With maths he should have cricket, with maths he should have hockey. So 2 more rows will be added. So this leads to unnecessary repetition of data and some other anomalies, that is your inconsistency and all things come into picture. So how do I convert this? I just have to decompose the table into two different things, with each multi-valued column attribute will go into a separate table. So SID and course will be one table, SID and hobbies will be another table. So with this I'll be able to overcome that particular problem of multi-valued dependency and the anomalies. The fifth normal form, very rare case, most advanced, where the table is already in 4NF and does not contain any join dependency. That is, joining should be lossless. You divide them into multiple tables. We also call this as project join normal forms. You define them into R1, R2, R3, Rm. One relation R is divided into so many things, and every Ri is a super key for R. That means the table is in 4NF and it can't have a lossless decomposition into any number of smaller table. You divide them in such a way that when you try to combine all of them, it should get back your original table. And remember, there is no more division is possible beyond that, because it is going to be the smallest divisions that are possible. All possible things we are going now see: agent, company and product. So we divide them into three different with all the combination: agent and company, agent and product, company and product. So which company gives which product, which agent is associated with which company, and what product he buys. So basically when we see that, because there is no multi-valued dependencies, you say that it is in 4NF and decompose them into three different relations, smaller relations, so that when join them back you will be able to get all of them. Look at this, extra rows are added, so this decomposition is a lossy decomposition. But if we perform the natural join between the above three relations, if I say P1 natural join, P2 natural join, P3, then no extra rows are added, so this decomposition is called as a lossless decomposition. So when I split them into in an order with which I will be able to reconstruct the original table, at the same time each what do we say, each product, each attribute is dependent on the key attribute there. Here when I say company and agent, agent determines company, and agent and product, company and product. So this is the higher normal form called as fifth normal forms. Generally in most of the decompositions we go up to 3NF, that itself would be sufficient. That is why these things are called as higher normal forms. In very rare cases we need to